Okay, so for 23, again, I want to point out there, they give you a polar equation, R equals, secant theta, tan theta, and then they say, oh, look at that, dy dx in terms of theta. And I'm confused by that. But really what they're asking for is what's dy dx in terms of theta. That's all they're asking for. So the first thing I get across to you that, the something that you should know in polar equations that x equals r cosine theta. And you should know that y equals r sine theta. You should also know that r is some function of theta. Now, so what's the function? It's right over here. All right, now what I want to do is I want to derive the derivative dy dx. Before I do that, though, I want to write down, let's see what we're going to write down over here. So I want to find the derivative dy dx. And what's that going to be? Well, let's be careful about that. It's going to be a ratio of dy d theta over dx d theta. And this is what your teachers probably derived in your calculus course. All right, now as I do this over here, I want to point out again that I get, f of theta cosine theta. Over here I get f of theta sine theta. So let's write this down. So let's do the dy d theta first. What do you get there? Let's see. You can get f of theta times the derivative of sine, which is cosine theta, plus f prime of theta times the sine of theta. All right, let's go to the bottom, which is going to be dx d theta. That's going to be f of theta. Let's see, times the derivative of cosine, which is minus sine, plus f prime of theta times the cosine of theta. All right, so we just derived the formula. I want to tell you where the formula is written in your notes, by the way, and I go through the derivation of it. It's written over here. All right, so it's really important that you get that formula because this is what dy dx is. All right, you have to get that formula. Now, someone says, if you were on exam, would you remember that? I'll be honest with you, I don't think I would have remembered that. All right, just because I'm not used to seeing it too often, and I would derive it. All right, now that takes time on exams, by the way. I will say if you're under pressure, memorizing certain things is important, though, and really important if you can memorize that. Now, someone says, what are you going to do now? Let me get my eraser out. I'm kind of done with this distraction over here. And what I want to do is I want to write down, what the function is. All right? So let's write this over here. And I want to make sure you understand that r, it's given to me as secant theta times tan theta. And I'm going to say this is a function of theta now. That's my f of theta. So what I want to do is go back over here, and I want to start writing this down now. All right? So I'm going to say it's a lot of writing, and I wonder if it simplifies out. It probably simplifies out pretty nicely. But let's write this down, and one thing at a time. I'm probably going to need a little more room, though, so I'll put it over here. So dy dx equals, and I'll put a really long fraction bar down here. All right? Looks like I don't have much room to do that. Let me write the eraser out. Let me try to be really careful with this. Oh, did it again. I'll get this erased over here. All right, let's start writing things down. So f of theta is secant theta times tan theta times cosine theta. Okay, we just did this part over here. Now I got to do the next one. It's going to be plus. I'm going to write down sine theta first. But what I realize now is I need the derivative of f of theta. So let's write that down. And that's going to be what? let's take a look. It's going to be a product rule. So secant theta tan theta times tan theta plus secant theta times the tangent squared of theta. Well, what do you get over there? Secant theta tan squared theta, and then you get secant, let's see if I did that right. I'm sorry, I made a mistake over there, I just noticed it. The derivative of tangent secant squared, sorry about that. And that's going to be secant cubed. I'm going to write that down now, and I have to be careful. So secant theta tangent squared. You know what I'm going to do before I do that? I notice that probably little factorizations might be in order now. So this over here, it looks like secant's going to pull out. And it'd be left off with tangent squared plus secant squared. All right, so let's write that down. And I'm going to write down secant theta. And then I'm going to get this tangent squared. Kind of hard to jam that in there, isn't it? Plus secant squared. All right, let's do the bottom. It's going to be minus f of theta. And f of theta is going to be secant theta tan theta. Times sine theta. And then it's going to be plus, let's see, f prime. I just did that. So it's secant theta. And then I get this tangent squared. Plus secant squared. And times cosine theta. All right? So I'm kind of looking around for something to do. And, you know, just a step at a time. All right, a step at a time. So what I'm going to do is I notice that, you know, whoops, sorry about that. I notice that the secant theta times cosine theta conditionally is 1. All right, so let's write that down. So I get tan theta. All right. And then what do I see over there? I see another tan theta because I'm looking at this now. And sine theta times secant theta is just tan theta. I'll write that down now. Whoops. And then what do you get? You get tangent squared plus secant squared. Now let's look at the bottom and see what we see over there. And I'm seeing minus tan squared now. Let me put what I'm looking at. I'm looking at this, and I'm looking at that. And the sine over cosine is tangent. So I see minus tan times tan, which is minus tangent squared. And then I see this, you know, the secant theta times cosine theta, which is going to be conditionally 1. So I'm left over there. Let's write down. I'm left with plus, you know, 1 times the tangent squared, theta plus secant squared, theta. All right? So let's take a look at it and see what I see. And looking at this over here, I notice on the top I can factor out a tangent theta now. And we left off with 1 plus tangent squared, theta, plus secant squared, theta. What do you get on bottom now? You just get, let's see, you just get secant squared theta. That's pretty nice. So things are moving in a direction that I like, but I'm kind of looking at it, I wonder where I'm going to go with this. Let's keep going. I get tangent theta. I'm going to use some trig identities, and what do I notice over here? That these guys over here, the 1 plus tangent squared is just secant squared. So I would get 2 secant squareds now. What do you get on the bottom? Secant squared. And again, there's a conditional cancellation. So what am I left off with? 2 tangent theta. All right, let's look at the key. And before I do that, it's a tough question, isn't it? I do see the answer. What's the answer going to be? It's right over here. By looking through the key, I realize that I do have work written down over here, and if you need to look at that work, that's fine. If it's a multiple exam, though, you're not going to see the work written there, of course, and someone says this is a really difficult problem. I found it to be like a little tedious, but it does move forward. Is there places where you could have made mistakes? Of course there's places where you could have made mistakes. I will say this, though, if you're making mistakes, you're probably not going to see the answer listed. But if you're on a multiple exam and this is taking you a half hour to do, you should not be taking a half hour to do something like this. You should go through it rapidly. If you can't get it, I'm going to say within a reasonable amount of time, move on to the next question. Come back to it when you have more, when you feel more confident about the questions you've already answered. Thank you.